So I've looked at the reaction and I want to know with respect to bromine. So there's a couple of different ways I can do that, but it's easiest if I can look at bromine directly so that I can see how the concentration of bromine changes with time. That's ultimately how I find out the effect of changing concentration on rate through my graphs. So suggest an experimental method. Now bromine is brown, so that's handy. We can use colorimetry. If we wanted, we could use carbon dioxide gas. So when you're looking at a reaction, if you didn't specifically care about bromine, if you wanted to monitor a reaction rate, you can look at, is there anything colored? In this case, yes. Titrations are often useful. Is there an acid on one side? Well, yes, but there's also an acid catalyst, and there's 2 H plus produced here. So there's too much H plus going on here to monitor a change in acidity. It's not a neutralization reaction. We're not going to use titrations. So we can use colorimetry or we can use gas. Colorimetry is easier because we are interested in bromine. So for colorimetry to work, the first thing you have to do is, colorimetry works by measuring percentage absorbance of a specific color. So if it says it's 80% brown, we don't know what that means in terms of what concentration of bromine would equate to 80% brown. So the first thing we need to do is make up known solutions. So make up solutions of known concentrations of bromine. Measure absorbance of these. Or just absorbance of these with a colorimeter and plot a calibration curve. And the calibration curve tells us what does 80% brown mean in terms of